Good morning, everyone. Welcome to Region 15. My name is Cynthia Holcomb, and I'm the Elementary Science Consultant for Region 15. So glad you're here today for our Elementary Science Overview. We're going to start the day by looking at the specs, or specifications, for elementary science. So we're going to look at the down and dirty of K through 5. And everyone should have this handout, the STAAR specs. We're going to spend a few minutes on this. Then we're going to transition into some activities to make sure that we do address everything that our students need to do to be successful on the STAAR test and also to be successful for junior high science. So when we look at these STAAR specs, I call the first column our essential 8. There are 8 process skills that spiral through our K through 5 TEKS that tell us this is how we do science. This is the process for science. And ladies and gents, let me tell you, these are embedded into at least 40% of our STAAR assessment questions. So if our students don't understand process skills, they're already at a great disadvantage. Okay, so that's the first note I'm going to make here, is I will see these skills embedded into 40% of our test. TEA said they did a little survey of the first STAAR test, and elementary actually came out closer to 60%. We're guaranteed minimum 40%, but it could be higher. Now, when it comes to safety, no matter what grade level you teach, this will be in your student expectation number 1. And we're going to look at that on your TEKS chart in just a moment. Safety has 3 components. Students have to know they have to stay safe for themselves and others. They have to know safety takes place both indoors and outdoors. Just because it's an outdoor lab investigation doesn't mean all bets are off. And then last but not least, safety for the earth. That's all right. I can't tell you how many times I've forgotten to turn off my ringer. Okay, so taking care of the earth, we're going to see this idea spiral through several of the TEKS. Not just in safety, but we'll see it in earth science and in life science as well. Now, when it comes to conservation, this is conservation of materials. This is also going to be found in your first student expectation, no matter what elementary grade you teach. And conservation is going to tell us we need to make informed decisions about how we use materials in science. Do we use it once and throw it away? Safe disposal of materials. Can everything go down the drain or in the trash? Because eventually, if it's in the drain or in the trash, it will make its way to our water supply, one way or the other. And last but not least, I mentioned use, and we've got reuse. Are there materials we can reuse safely? Any questions so far? All right, then if you look at student expectation number 2, no matter what grade level, you're going to be told there are 3 types of investigations that our students need to know in order to be successful in science. And the first is a descriptive investigation. And that simply means we need to know how to describe in science. We can describe mass, length, color, texture. We can describe a sequence of events. And in K through 2, this is the predominant investigation, knowing how to describe. Makes sense. We're still working on language skills. A little further up in difficulty will be the comparative investigations. And we're still describing, but now we're describing more than one object or more than one event. So we compare the two. We look at the descriptions and see how are they alike, how are they different. Anytime you use a T-chart or a Venn diagram, you're probably doing a comparative investigation. Now I mentioned K through 2 specifically states descriptive investigations, but when you look at your TEKS, sometimes the verb will say compare, sort, and that lets us know we're expecting a comparative investigation. Okay, here's the big deal. 5th graders, you're tested on experimental investigation. In experimental investigation, all of a sudden we have variables. We have repeated trials. We have to look to make sure that we don't change more than one item in the investigation. It means there's going to be a question. So we're really getting into the heart of investigation, true experimental. And that takes us to problem solving. We're going to transition into that in just a moment. Right now, I'd like to stop and let you talk at your tables of anything we've covered so far.